We've been looking at the law of sines and law of cosines, specifically applications of them, and some interesting things that pop up when we employ them. Today in this lesson, I will answer the question, where do the law of sines and cosines come from? Now, let's begin with my generic triangle. Angles ABC, side lengths ABC, opposite to the angle. If I run a perpendicular line from the tip, meaning this is a right triangle on this side, a right triangle on this side. I'll call this height h. Quite simply, h is equal to hypotenuse C times the sine of angle A. But it's also equal to hypotenuse A times the sine of angle C. So you can see that these two sides are equal to each other. Now if I divide both sides by AC, C's cancel here, A's cancel here, and I'm left with sine A divided by A is equal to sine C divided by C. You could rotate the triangle and make a similar argument for sine B over B. Thus, the derivation for the law of sines is quite simple. For the law of cosines, I'm going to position my generic triangle such that corner A rests on the origin, 0, 0, of my xy Cartesian plane. That would make this point, in terms of xy coordinates, equal to b, 0. And this point up here would be hypotenuse C times the cosine of angle A for the x coordinate, and hypotenuse C times the sine of angle A for the y coordinate. Now suppose I want to solve in terms of side length A and angle A. Now to do that, I'm going to calculate the length of this line segment given the coordinate pairs and show that it is equal to A, as defined here. So to do that, x2 minus x1 squared, b minus c cosine of A, quantity squared, plus y2 minus y1 squared, 0 minus c sine of A, quantity squared. So of a right triangle, we have this leg squared plus this leg squared is equal to hypotenuse A squared. All right, FOIL this out. I get b squared minus 2bc cosine A plus, remember negative times negative is a positive, plus c squared cosine squared of A. Plus, well, we have a negative times a negative is a positive, c squared sine squared of A is equal to A squared. At this point, I can factor out a c. C squared times cosine squared plus sine squared. Well, remember from our trig identities, this whole term is equal to 1. So I'm left with b squared minus 2bc cosine of A plus c squared is equal to A squared. I can rearrange it a bit so it's in a more familiar format. B squared plus c squared minus 2bc cosine of A is equal to A squared. Now here, what's important is that capital letter A, representing the angle, is on the opposite side of lowercase a, representing the side length. By rearranging the letters on my generic triangle, I could obtain the same result in our more familiar format. C squared equals A squared plus B squared minus 2AB cosine C. These letters are mere symbols, so it doesn't matter what order we put them in as long as we're consistent and keep track of what we're doing. I hope you were able to follow along with my derivation and make some sense of where our laws of sine and cosine come from. Let me know if you have any questions in the comments section below. If you enjoyed this video, please like it and subscribe to my channel to get more videos in the future. Thanks for watching. I look forward to seeing you next time for another adventure.